In this video, I'm going to show you how to draw the electrons for a few of the elements we'll be dealing with a lot in this chapter. So first up, we need to look at a periodic table. You'll notice on a periodic table that the whole numbers represent the number of electrons and protons. So starting with hydrogen, moving to helium, you'll notice it's 1 and 2, and then as we move across, it increases. Knowing the total number of protons and electrons is necessary for us to draw the correct number of electrons. In this video, we're also not going to focus on the nucleus much, so we're just going to draw it as a dot. So there's our nucleus. Now for hydrogen, we want to draw how many electrons it has, and we want to make sure that they're in the correct location. So first up, we have the first energy level, and since hydrogen only has 1 electron, we're going to just draw it in that first energy level. These dots on the rings represent the electrons, and the dot in the center is going to represent the nucleus. So let's go across to helium. Nucleus, first energy level, 2 dots. These represent the 2 electrons that helium has. Now notice that they're paired together. Most electrons will eventually pair up in what's called an orbital. The valence electrons, they do this, but when they're involved in bonding, things change a little bit. So the way that we're going to draw these, we're going to draw them as if they're ready to bond. Now we move from helium to lithium. So our nucleus is a dot. Our first energy level can have 2 electrons. And if you notice, lithium has 3 electrons. So the last electron is going to be in its second energy level. So it'll look something like this. Beryllium has 4 electrons. The first 2 are going to be in the first energy level, and then the second 2 are going to be in the second energy level. Now again, because beryllium is involved with bonding, we're actually going to draw them across from each other. So they're not going to be next to each other, which again looks odd, but again, it has to do with bonding. And then boron. Boron has a nucleus, 2 electrons in its first energy level, and then we have to get up to 5, so there's 3 in the second energy level. And they're going to be as far away from each other as possible. So they're going to form sort of like a triangle. If you connect the dots, you can kind of see the triangle there, right? Carbon has a nucleus, 2 electrons in its first energy level. So 2 plus 4 will give us 6. So it's going to have 4 in its second energy level. If you were to imagine that carbon or any atom has a box around it, this is where the rest of the electrons are going to go. They can either go on the top, the right, the bottom, or the left. So for carbon, nitrogen, oxygen, fluorine, neon, they'll all kind of adhere to this. There's 4 sides to it. Okay, so right now we put 1 and it's on the top. So we're going to put another one on the right, and then 1 on the bottom, and 1 on the left. And they'll actually just kind of fill them up in this order as you move across. So carbon will look like this, where there's 1 on each of the 4 sides. Nitrogen, which has a nucleus, it has 2 electrons in the first energy level, and then it has 5 electrons in the second energy level. So if you put 1 at the top, 1 on the right, bottom, and left, now you just need 1 more. So we would put it also on the top. So that's what nitrogen would look like. Oxygen will look similar. So you have a dot, you have 2 electrons here, and now it's going to have 6 in the second energy level. Now, with nitrogen and oxygen's 2 paired up, you can have them on any of the sides, the top, the left, the bottom, and it would still work. All right, so nitrogen could look like, and then for that other double pair, you could have them maybe on the side. That's fine. The one rule with oxygen is you have to have them next to each other. So if you take a look at it, what do I mean by next to each other? I'll show you. So if you put a double on the top, the other double could be on the left side or the right side. It just could not be across. You couldn't have doubles across there. And that again has something to do with the shape, which we'll get into later on. All right, then we have fluorine. Fluorine has 1 dot for the nucleus. It has 2 electrons on the first energy level, and then there's 7 in the second energy level. So it's And then finally we have neon. where the second energy level is completely filled. So that's the second energy level. Sodium and the third energy levels, they're going to look very similar to the second energy level. So let's go through them. First energy level has 2. Second energy level now has 8. And then the third energy level has 1. All right, and again, notice that it's got that one dot, which looks similar to this one, which looks similar to this one, right? So everything in this group is going to look the same, meaning that it's going to have 1 electron in its outermost energy level. Okay, here we go. Okay, so let's talk about these real quick. So sodium and lithium look very similar, and even hydrogen. They have 1 electron in their outermost energy level. Magnesium and beryllium, they all have 2 electrons in their outer energy level. Boron and aluminum have 3 electrons. Carbon and silicon have 4 electrons. Nitrogen and phosphorus have 5 electrons. Oxygen and sulfur have 6 electrons. And then fluorine and chlorine have 7. And then the weird thing here is this just has whatever its outer energy level is, it's completely filled. So helium, it's the first energy level. It only has 2, but they're filled. It has 2. And then as you move from neon to argon and then going down from there, they'll have 8. All right. So this is kind of a weird one. The first one is only going to have 2, but everything after that's going to have 8. So you can see there's a pattern here, right? 1, 2, 3, 4, 5, 6, 7, 8. All right. So as you move across, it increases. So even though it looks like there's 18 completely different elements here, if you just learn the pattern, it'll make it a lot easier for you to remember. I would highly recommend you rewrite this a couple times just to kind of get the flow of it, to understand what's going on. If you have any questions, feel free to put them in Google Classroom, and I can help you out with that. And again, the drawings here are important for you to know where the electrons are located, because we're dealing with bonding later on, and that'll help with that. So again, if you look at certain references in the book and whatnot, they may look slightly different, but again, I'm showing you something that's a bit more advanced than our textbook.